I'm Shen Huang. Our project is the point of interest content-based recommendation. In this video, Yichou and me, Shen Huang, will talk about our work in this topic in the Foursquare dataset. And the next video, Monica and Meridina will talk about their work in the YEP dataset. First is a POI, point of interest. This is a specific point location that someone may find interesting or useful. A common way to do this kind of task is using the checking and comment state of this user to generate a model to recommend a new place or location that the user may be interested in. This is a YEP dataset. In this video, we will not cover the YEP dataset, and Monica Meridina will talk about this part in the next video. In this video, we'll talk about the experiment based on the Foursquare dataset. First, Foursquare dataset is a location-based social network dataset that has massive user and their footprints. We mainly use their checking tips and comments data of the restaurant for recommendation. After cleaning the data, we are using the checking data and comments tips data to generate our model and do prediction task. For the checking data, the first column is user ID and second column is venue ID, which is POI ID. And for the next is comment and tips data. The first column is user ID and second column is venue ID. And the third column is the tip comment text. And in the first Square dataset, we want to do recommendation task in it. First, we try one kind of recommendation system algorithm called content-based recommendation and try some methods in it. Then we use another famous recommendation system called collaborating filtering recommendation. In this task, we may use different matrix factorization methods. First is task 1, the content-based recommendation. We get the separate embedding of user and POIs, and then recommend the most similar POI to this user. Content-based here means we learn the representation of the user and POIs, and then we use cosine similarity between the user and POI, and then do recommendation. The task is we have a users with history, and then we want to have some possible POIs. We want to recommend some POIs that users are likely to come. For example, one user has visited POI 1, POI 2, and there are some possible visiting POI 4 to POI n. We want to recommend one or more POIs to this user based on the user's actions we have known. So for each user, we generate a model. We randomly pick some visited POIs as ground truth for test, and other visited locations are used for training the user's representation. So for the training part, each user has some visited locations, and there are some comments and tips. And for the test part, users visited POIs and other random picked POIs. We generate 4 datasets for train and test. First is train 10 based on the user's history actions, and the test size is 10 and only one of the POIs is true. And train 20 and 50 and 100 is similar. And this is our pipeline for our task 1. First, we process the tips, comments, text, and generate a text for train and test. And then we use our methods to get the vector representation. The methods we'll talk in detail next. And then, based on the similarity of the vector representation to do the recommendation. And Cho will talk about the evaluation part and our first methods to do this task.
Hi, I'm Yichou. Now I'm brief talk about how to evaluate. We use MNR to score it and average the score over our user. Give a simple example. A is the proper one whose rank is number 1. And there are 3 predictions. The first one gets score 2/3, and the second get 1, and the final one get 1/3. Then I will demonstrate the method we use to predict the similar place for the user in the following. And there are 3 steps. The first step is to convert comments to vectors. And the Second, we will construct the models and we will compare three different models. And the final step is to use the constructing model to do predictions. First, to predict the specific user, we convert the user comments to vector representations. In the progress, we define a sublist including for, of, and so on to ignore the words which are too often used. That is no information. Then we construct a dictionary from those collected words and further convert the text into vector as corpus. Second, we try three different models. The first one, the LSA model, is our baseline model. And the second is TF-IDF model. The third one, random projection model, which gives us the best prediction in our study. Here, I briefly introduce LSA model. The main idea of LSA is to use singular value decomposition to reduce the number of feature dimensions. The potential chance that the dimension can be lower is that some combined feature can represent a more significant feature than one term. For instance, there are three features: car, trunk, flower. In some situations, a feature combined car and trunk may be more important than only car or trunk. So we can reduce the dimension from 3 dimensions to 2 dimensions. And the random projection model is similar to LSA model. The author proposed that the random indexing of text simple for LSA will yield more accurate predictions. So it will create the random projection matrix to do prediction. Then once we have the model, to predict the proper place to user, we convert the test vector to LSA space and calculate its similarity by taking the cosine of angle between the two factors. After all, we select the place with the highest similarity to recommend to the user. Now we see the result. For the last three test samples, we improved the score a little by random projection model. But for the first test sample, it didn't improve. And to note that the number typing means the number of request factors. In our trial, we don't need too large feature dimension in constructing our prediction model. And then
Okay, thanks. So I will talk about the method 2 and the next task 2. First is the overview of the method 2. The first step is using the word2 vector to get the word embedding, and the second step is we average the word vector in each columns, and then we can get the representation of the user and POI. And our prediction is based on the cosine similarity between the user and POI. And this is the result using the word2 vector plus the average method. And you can see the word2 vector is better than the method 1 because the BOW model cannot get the semantics meaning of the comments. And then for the task 2, the matrix factorization based collaborating filtering recommendation. This is based on the checking dataset and user ID and POI checking times as the rating for the POI. So this can generate a rating matrix. Now we can use the matrix factorization method to do the collaborating filtering and get the prediction of R. Now we want to minimize the formula below. RUI here is the user U to the POI I's rating. And the end of the formula is the regularization part. We want to get the unknown RUI. We can use a stochastic gradient descent to solve the optimization problem. And this is the trend and test dataset. For example, if one user comes to one restaurant 4 times, the rating is 4. This is we can know the user to POI's ratings matrix. We can do cross-validation on the dataset. Just remove some cells in the rating matrix and then use one part as text, another part as the trend. And for the evaluation part, we mainly use the RMA SE and MAE, which is root mean square error and mean absolute error for evaluate our different models. And the pipeline for the task 2 is that first we'll get the training dataset and then convert to the matrix format. And then we'll do cross-validation to split the train and test data. And then we'll try different matrix factorization models to see the prediction performance. And this is model overview. We try 4 different models to do the recommendation task. The NMF is our baseline, which is a collaborative filtering algorithm based on the non-negative matrix factorization. This is the simplest matrix factorization method. And then the SVD, which is a famous recommendation algorithm, as is popularized during the Netflix price. Now I have some bias in the SVD algorithm. And next is a PMF, which is a probabilistic matrix factorization algorithm. Now here, I has no bias, and this is very similar to the SVD. And then the SVD++ algorithm. This is an extension of the SVD, which takes into account of implicit ratings. And then this is a result of the 4 different methods based on the 4-square dataset. And we can see the PMF, the probability matrix validation method, has the best performance based on our experiment. And we do the 5 cross validation in the dataset. And the MAU, which is also the PMF, has the best performance on our experiment. And in the future, for task 1, we need to, because this is a content-based algorithm, we need to solve the cold start problem. We may recommend some hot POIs to the user. And also we can use paragraph to vector to replace the word to vector to get user and POI vector representation. And in this work, we don't consider the semantics meanings of the POIs. And this can be solved. And in the task 2, the rating matrix is too sparse. Maybe you can remove some POIs to get a higher performance. And this is reference for our work. And next, Monica and Merida will talk about the experiment on the YAP dataset for recommendation. Thanks.